नमस्ते बच्चों. Myself Om Prakash Kesari, Faculty of Department of Science and Technology under Faculty of Education and Methodology, JAYOTI VIDYAPEETH Women's University, Jaipur. Today I taught you matrices. In your last class, I will see some definitions and of a matrix and how can we find the order of a matrix. That means two things. One is the definition, second is the order of a matrix, and also see some applications of the matrices where the matrix theory will be used in our real life. And one of the famous example is also ATM machine. That means ATM, including ATM card, WhatsApp chatting. That means any chatting app, and Facebook app, which are encrypted. Now, in matrix theory is matrix theory is the subject of number theory, theorification, and matrices, which are taught in B.Sc, B.Ed, PCM first semester student, or also B.Sc first semester student. These are the lesson planning which are already discussed. How can we plan a lesson in your first lecture class? These are the steps for planning a lesson which are already discussed in your first lecture class. These are the components of a lesson plan which are already discussed in your first lecture class. Now, the matrix theory, I will see today some more example on matrix. In your last class, I will see order of a matrix. First, definition of a matrix and then order of a matrix. And we will define order of a matrix as a matrix having m rows and n columns is called a matrix of order m by n, or simply m by n matrix. It will be read as m by n matrix. And some examples on this one. In general, an m by n matrix has the following rectangular array. That means it can also be represented as A equals to under bracket Aij m by n, where Aij represents the element of all the elements and m by n represents the order of the matrix, where I belongs varies from 1 to m and j varies from 1 to n, and I comma j belongs to n. The above notation is the mathematical notation, and the detail of this notation will be shown in this figure. This figure, that means A11, A12, A13 dot dot dot, A1j dot dot dot, A1n. Now look here, A21, A22, A23 dot dot dot, A2j, A2n, A dot dot dot, AI1, AI2, AI3 dot dot dot, Aij dot dot dot, AIN. Similarly, the last one is AM1, last row, AM2, AM3, AMJ dot dot dot, AMN. Now look here, the element this one, AIJ. It represents the ith row and jth column. Ith row, that means 1, 2, 3 dot 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 I, and jth column 1, 2, 3 dot 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 J. Ith row and jth column. Ith row and jth column. This is very important to understand. If you understand this table, then the matrix theory will be easy. Now again, see these things. A equals to Aij m by n. That means, and I varies from 1 to m. Now look, and j varies from 1 to n. Then their total number of combination will be m into n. Now I equals to 1, j equals to 1, 1 1, A11, first row, first column, A12, first row, second column, A13, first row, third column, dot dot dot, A1j, first row jth column dot 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 A1n, first row n column. Similarly, A21 second row first column, A22 second row second column, A23 second row third column, A2j dot 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 A2j second row jth column dot 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 A2n second row nth column, second row nth column. Similarly, we can move further. AI1 that means ith row first column, AI2 ith row second column, AI3 ith row third column, AIJ ith row jth column, element of ith row jth column, AIN ith row and nth column. Similarly, AM1 mth row first column, AM2 mth row second column, AM3 mth row third column dot 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 AMJ mth row jth column dot 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 AMN mth row nth column, and the total number is m into n, that means mn. Thus we can say that the ith row consists of the elements a, I1, I2, I3, ith row, this one, I1, I2, I1, ith row, this one, ith row, I1, I2, I3 dot dot ij dot dot in. Similarly, jth column consists of the element, this one, jth column, A1j, 2j dot dot ij mj, ij mj. That means here we see ith row and jth column, ith row and jth column. This is very important. Therefore, in general, Aij is an element lying in the ith row and jth column. That means indirectly we can say Aij is representing the element in ith row and jth column. We can also call it at in the vector notation as ijth element, ijth element of A. The number of element in m into n matrix will be equal to m into n, which already we have discussed. Now, this is the general representation of a matrix. In pictorial, in pictorial, this is the exact matrix. Or mathematically, we can represent this matrix as A equals to under bracket Aij m by n, or we can say m into n. It will represent a matrix of order m by n, where Aij represents the ith row element of ith row and jth column, and I and j varies. I varies from 1 to m and j varies from 1 to n, because number of row will be m and number of column will be n. Number of row will be m, number of column will be n. Now, next we move to the types of a matrices. There are various types of matrices. In this section, we will discuss some different types of matrices. The first one is the column matrix. Very simple. Column matrix. A matrix is said to be column matrix if it has only one column. A matrix is said to be column matrix if it has only one column. And I already say that all these things are basic. That's why we will explain all these things in brief, not in detail. After that, we will see the advanced part of the matrix theory, which are your last unit of this in unit. That means unit 4. This is the unit 3 chapter, unit 3, in which some basic concept of matrices will be there. Matrices, order of a matrices, algebra of a matrices, that is addition, subtraction, multiplication, and then inverse of a matrices, symmetric, skew symmetric matrix, all are there in this unit. The first one is the column matrix. That means the matrix which contain only one column is said to be column matrix. For example, if A equals to 0, root 3 minus 1, 2 is a column matrix of order 4 by 1. In general, A equals to Aij m into 1. M into 1, that means J must be 1. In column matrix is a column matrix of order m by 1. Is a matrix column matrix m by 1. And next one is the row matrix. Row matrix, a matrix is said to be a row matrix if it has only one row. It has only one row. For example, b equals to minus 1 by 2 root 5 2, minus 1 by 2 root 5 2, minus 1 by 2 root 5 2, 1 by 3. That means it has only row. The other one has only one column, and this one has only one row. And in general, this is can be represented as b equals to aij. You can also write bij. When we use two matrix, then we can write a ij, bij, cij, dij for the sake of convenient. And here b equals to aij 1 by n is a row matrix of order 1 by n. Next one is the square matrix, a matrix in which the number of rows are equal to the number of columns. The number of rows are equal to the number of columns. That means m equals to n is said to be a square matrix. Is said to be a square matrix. I will see some examples on all these matrices and a lot of different types of matrices in your next class. In your next class, I will discuss all these things. This session is powered by the digital version 2.0, JAYOTI VIDYAPEETH University, Jaipur. And I hope all of you are satisfied with my digital session. If you have any queries, please mention in the comment box. I will try to resolve it. Thank you for watching my this lecture video. Thank you, bachcho.